So I'm Lily. I'm from Lycoming College, which is in Williamsport, Pennsylvania. And this summer, I was doing work on carotenoids and how they affect pollen fitness in tomato. So just to give a very quick overview of what I found this summer was essentially using a wild type tomato and a tomato which is mutated in the enzyme that kind of kickstarts making carotenoids. I was able to find that in the tomato with less carotenoids, the pollen does not germinate as well. And when it does germinate, the tube lengths are much lower than in the normal tomatoes. So I kind of wanted to see what pigment was causing that. So the two that are mostly different between the wild type and the mutated tomato are beta carotene and lutein. So there's been previous research on lutein. That one doesn't make a big difference to the pollens. So I decided to look at beta carotene. And what I found by growing the mutated pollens in the beta carotene was that they germinate better. And they also make longer tubes. So essentially, beta carotene kind of helps them grow more often and better. So just to kind of complete the circle of what is affecting these pollens, we are wondering how the pigment is allowing the pollens to grow better. So essentially, we found the mutant pollens had more reactive oxygen species, so that could cause damage to them and cause them not to grow as well. And just to kind of double check this hypothesis, we added ascorbate to the mutated pollens, and we found that that compound, which kind of takes away reactive oxygen species, allowed the pollens to germinate better. So in essence, more carotenoids, less reactive oxygen species, your pollen can grow better, and that's good for fruit yield and fruit set. And yeah.
That's fascinating research. Thank you for sharing it. Did you find this surprising at all, or was this kind of?
This is kind of what we. Sorry, no, you're okay. This is kind of what we were expecting because carotenoids are known to be antioxidants. So, and in general, that's a good thing. So, if we were to take reactive oxygen species away from AC, that would be bad. You need a little bit of reactive oxygen species for like signaling, but when you have this many, that's a bad thing. So we kind of had an idea that the carotenoids would be helpful for the pollens. Yeah.
Well, that's why lutein wasn't as important. Is lutein much of an antioxidant?
I think beta carotene is one of the most well-known antioxidants, so I think it tends to be stronger. So maybe that could have been the reason why. Yeah. Yeah. Well, thank you.
Thanks so much. Fabulous work this summer. Are you interested in pursuing carotenoid pathway in the future, or has this helped you decide on a future career avenue at all?
So I've done some work with carotenoids and bacteria in the past, and I really like that. So this is kind of just adding to the evidence that I like working with carotenoids. But to be honest, there's so many fun things to research out there. I can't narrow it down quite yet. So yeah.
Yeah, that's fair. It's very difficult. And just the amount of research in this room alone is overwhelming. Oh, well, thank you so much for chatting with us. Have a good one.